Okay. Good afternoon, everyone. My name is Sabrina Kofer, and on behalf of Choice and ACRL, I'd like to welcome you to today's program, Beyond Bibliometrics, Using Scopus to Assess Collections and Support Faculty, which is sponsored by Elsevier. This session is one in a series of sponsored webinars from Choice and ACRL that addresses new ideas and developments of interest to the academic library community. Before we get started, I'd like to point out just a few features of the webinar software. All of the attendees who join the presentation are automatically muted and your cameras are off, so don't worry about generating any noise or feedback. We've got that taken care of for you. In the main area of the screen, you can follow along with the presentation materials. To adjust the size of the slides or video, you can use the divider in the middle of the screen to slide the sizes to your liking. We are using the Q&A feature today. Please use it to ask questions of our speakers. We do expect many questions, and we likely will not have time to get to all of them. But that being said, we'll answer as many questions as we have time for at the end of the presentation. So please do type your questions into the Q&A module as they occur to you. You can also use the upvote feature to highlight questions that you like or would like to be addressed. Also, there is closed captioning available for today's session. To toggle the automated captions on or off, please use the CC button on the bottom right corner of your screen. Last, please note that we are recording today's program and everyone who registered should receive a follow-up email with a link to the archive version. And with that, we are ready to get started, so I will hand it over to Emily.
Great. Thank you so much, Sabrina. I'm so delighted to be here. It's wonderful to have the opportunity to moderate this ACRL Choice webinar with all of you. So my name is Emily Singley, and I'm the Vice President of North American Library Relations here at Elsevier. And I'm so thrilled to be here. This is going to be a really interesting session, I think, where we're going to learn about two use cases on how librarians have been able to use the Scopus Data Fetcher tool to query Scopus data in interesting ways without needing to code. So our speakers today are Lori Ostapowicz-Critz, who is the Associate Director for Scholarly Communication and Open Strategies at the Worcester Polytechnic Institute in Massachusetts. And we also have Julie Morris, who's the Collections Analysis Bibliometrics Librarian at the University of New Brunswick in Canada. And my colleague Eric Livingston is joining us today. Eric is an expert on the Data Fetcher tool, and he'll be telling us more about how we can use the tool. So, and as Sabrina mentioned, I encourage you all to think about think about your questions as we go through the session. And please feel free to put them into the Q&A, and we'll get to as many as we can at the end of the session. So with that, I will go ahead and hand it off to you, Lori, to get us started.
Great, thanks, Emily. All right, so I just want to tell you a little bit about my wonderful institution as I get started here. So WPI is, of course, very well known for its engineering program, but probably the second thing we're most known for is our real emphasis on project-based education. So we work with about 70 different project centers now around the world, and most of our students get a chance to visit and work at one of these great project centers. We're in the top 20% of US college rankings from the Times Higher Education polls. As you can see, we've got about 6,300 FTE and just the most remarkable students that you'll ever meet. So I'm very proud to be here. We work with about 600 incredible faculty who are dedicated to not just research, but teaching as well. And as I say, I feel so lucky to be here and to work with these marvelous students and faculty. So my use case, I think I am going first in this because my use case is one that is quite practical and really, I would say, small compared to some of the other use cases that could come up. So I call it a universal issue because our faculty, like faculty across the globe, have to prepare promotion and tenure packets. Increasingly at WPI, and I suspect elsewhere, faculty are being asked to demonstrate impact at a global level. So when I started doing this many years ago, often just a publication list was all faculty needed for their packet. Recently, in the last 10 years or so, they're required usually to submit some sort of citation analysis at the same time. Well, to do that basic citation analysis, Scopus has been wonderful and very easy to use. So As most of you probably know, it's very easy to pull any of the traditional citation data. You can go in by the author search into the author profile and get that data and export it to Excel or whatever very easily. And Scopus, of course, will automatically generate things like the H index for the author. So that's been a real godsend for me. But increasingly, I've been told that they need to have additional data if they really want to tell the whole story. So we found that social media data has become quite a critical component of this impact story that they're trying to tell. And as probably most of you again know, Scopus provides the PLUMX metrics at each record level. So each record will have that. I've included the definition there of what they mean by PLUMX if you're not familiar with the PLUMX metric. So as it says, it really is just a way for providing some insight into the ways people across the globe are interacting with the individual pieces of research output. And so this includes everything from tweets to favorites to shares to likes, downloads, captures, readers, mentions, etc. So there's a wide variety and a wide array of PLUMX metrics that are included in Scopus. And this has become a really great addition to the bibliographic analysis that I do for faculty. The problem with it has been it's not easy to capture. Basically, I do this for each record. I have to copy and paste any of the data that I want from the PLUMX site or directly from the Scopus record. And so it takes a great deal of time and energy to do that, particularly since some of our faculty, not surprisingly, have, several hundred articles and other measures of scholarly output that they've produced over their careers. So then I discovered the API, and the reality is I did not discover the API. The reality is I started, sort of lamenting the amount of work that it took to do this. And I started talking with the Scopus Elsevier rep, who was just wonderful in working with me. And the rep finally ended up saying, you know what, this sounds like a job for an API. And about all I knew at that point about an API was that it's an application programming interface and that it was a way for two tools, I guess I will call them, to talk to each other, two interfaces. And that's really all I understood about it. But I said, sure enough, I'm willing to give this a try. So I was introduced to the data fetcher. Eric and Kyle were very kind to do some demos with me. And I will tell you that the very first thing I felt when I saw a demo of this tool was that I felt like I had won the lottery. So what used to take hours and hours and hours of work, I could now do in minutes. So instead of having to go into a record and pull each piece for the PLUMX metrics, I was able to pull it pretty automatically. And to get started, all I needed was to get the API key from Elsevier site, and Eric will talk about that a little bit later. You need an institutional key or token if you're going to do this when you're not on an IP address recognized by Elsevier. And then, of course, you need the data fetcher client. And I will say that Eric has done a remarkable job in developing that client. And I think I've been to about 3 versions, and every one gets easier and easier for a non-coder, a traditional librarian like myself, to be able to use. So it's really wonderful. It works really well. So when I'm using the data fetcher, then what I'm really hoping to do then is to help the faculty tell their story by particularly capturing that PLUMX metrics data. So again, you have to enter your API, and you certainly have to enter the institutional token if you want to work off campus with it. And then the next thing you worry about is developing the query. So what are you going to ask about whatever you're researching? So I've got just a quick example up there to show you. It does come, this is pretty close to what comes sort of out of the box when you first open it up, as you can see. These might look very familiar. These are the same commands that you would use in the advanced search feature in Scopus. So you don't have to learn anything new. You don't have to worry about being able to code or anything, that you use the the same query that you would use there in the advanced search, and that's actually how you can build it if you choose to. So in this case, if you look at the query, this one in particular is looking for an affiliation. So it's looking for a particular place, an institution. It's saying, look at, the records in Scopus since 2003. It's limiting it to 2 document types, to articles and conference proceedings, and it's saying that they must be open access. So that's a pretty limited search there, perhaps, but again, could answer a specific use case. So in my case, I'm looking at an individual, so I have to use an author ID. But again, the rest of it I keep pretty similar to this, and using a publication year that I'm going to set for when I want to go back and pull the data from, and perhaps might limit to document type or other things as well. So again, building that query is very, very simple. Okay, after you build the query, then you just tell the data fetcher what it is that you want to capture. So under the fields that I've highlighted there in blue on the data fetcher, you start adding the fields that you want to have output in the end. So in my case, I want all the plum metrics. So I just ask it to include some basic data so that I can tie it to which title am I getting this PlumX metrics for. And then I start adding all the PlumX metrics that I want to include. And again, it might be just 1 or 2, but if I want to get the full picture, I can add them all in. And again, the interface makes it pretty easy. As you can see, you click on edit, then you click on add. And if you look very far to the right, there's now a little window where you really just select the ones that you want. So you can go down on this particular window and start using your control key and select as many as you want at a time and add them into your output field. I think by default now, Eric has made it so the outputs will come in Excel if that's an available format for the output that you need, but you're going to see that there's others as well. At that point, you are ready to begin. So you just click on begin and run. You can watch your query build there. It'll tell you how many that it's found, so you know if it's working or not. When it appears to be done, if you look at the run, it'll tell you what it's actually run, and then the output will tell you where to locate your data. And again, I want to stress, no coding involved at any point. Even though it looks like a lot of code here, the code is all internal, and as a user, you really don't need to worry about that at all. And here's what my output looks like, what I need to get. So I want it in a spreadsheet format, either, Excel works fine for me. I do have to admit that there's a little bit of data cleanup that you're going to do, but that would be true no matter how you captured that data. So it's possible that I rename fields, that I move things around, I remove some fields, etc. But it really is a very, very nice usable format right there. Okay, and from there then, the final result on this is I use this as part of the research analysis, the publication impact report that I create for the faculty member. Typical one here for a senior researcher was 29 pages. And if you look to the right, then you can see that this is what I ended up with for a spreadsheet for all of the PlumX metrics. In this case, I think it was 4 or 5 pages long because it was a very prolific researcher. But the faculty they love it. They're very appreciative of this work. And for me, it's a lot less stressful. So as a librarian, it's just wonderful. This year, I'm going to be adding things from SciVal. For example, I can add collaborators in here and then turn that list into a graphic using something like the VOS viewer. I'm also going to be adding the site score so that I can get some metrics at the journal level for the quality of the journals that they're producing publications in. And I'm also going to capture the topics through SciVal. So the Scopus topics, so I can create tree maps that the faculty just love. And really, again, the whole thing is it tells their story. All of these graphics and data help to tell the story and help to show their impact on the world. Great. With that, I'm going to turn it over to Julie.
Thank you, Lori. That was awesome. My name is Julie Morris. I'm the Collections Analysis and Bibliometrics Librarian here at the University of New Brunswick, which stands on the unsurrendered and unceded traditional Wolastoqey land. So I'm going to go through this pretty quickly. I'm just having some issues with the slides, so apologies. Okay, perfect. So I'm going to start with an introduction to what collections analysis, bibliometrics, how they intersect, and then talk about a citation analysis project that I've been working on for the last year. I'll talk about some implications and lessons learned, or limitations and lessons learned, and some applications and next steps. So as you all know, the cost of digital library serials continues to rise and budgets are often stagnant. With this in mind, there is an urgency to come up with creative ways to look at our collections so that when it comes to time to make big changes, we're better prepared. So I will be talking about a citation analysis, which is a methodology at the crossroads of bibliometrics and collections analysis. So some of the questions that I've posited throughout the process of doing this project are, how will this project help us unbundle our big deals? To what extent does our collection meet our authors' research needs? And do gaps in our collections holdings adversely impact our authors' research? So I don't have answers to all those questions, but I do hope that I will by the end of this project. So what is collections analysis? It's a way to analyze the strengths, engagement, and costs associated with the library's collection. It's used to help make strategic acquisition, renewal, and retention decisions. Usually we rely on what are called counter reports, which are verified usage reports that provide standard metrics across different vendors so we can compare them. One of the limitations with counter reports is that we don't know who's actually using the resources or to what extent. So now I'll talk about the project that I undertook in citation analysis. So citation analysis is a branch of bibliometrics that examines the citations found in publications, such as journal articles and books, to look for patterns of use. And that comes from Hoffman and Doucette in 2012. So I do caution that we not necessarily jump to the conclusion that highly cited references are necessarily the most impactful. But one way we can discover this is through citation analysis and get a sense of who's using what. But I would suggest that we go a little bit further in our analysis and maybe talk to researchers about how they're using those sources that they're citing. So a little bit about UNB. We're about 10,000 students. And one of the interesting things about UNB is that we're responsible for about 70% of sponsored research in New Brunswick, which makes us a very pressing topic to understand what kind of research is being done in our province, not just at our institution. So I conducted a user study citation analysis where I analyzed publishing authors' research trends, including faculty and graduate students. I used Scopus as a data source from 2019 to 2021. I looked at about 120,000 journal publications, and I'll show you how I did this. And it's still a work in progress and will be for quite some time. This is my process. And I borrowed the methodology from data mining, which follows extract, clean, and analyze. I used 5 different softwares for this project, including the Scopus Data Fetcher, OpenRefine, which is a data cleaning tool, Microsoft Excel, Microsoft Access, and Power BI. Now, this is the full workflow that I went through. It's a bit small, but it'll be in the recordings. And if you want a copy of this, this chart, just reach out to me and I will provide it to you at the end of the session. So the first step to undertaking this project was to extract your publication data. So I used the API to pull all the publications from my institution in that in that time frame, 2019 to 2021. And then I pulled a list of all of the citations that were listed in those publications. So I was able to feed the publication ID through the data fetcher to get the citations. So that's what I did here. You can see on the left, I had a list of citation, had a list of IDs, and then I fed it through the data fetcher. And then I pulled the record into, or I exported it and I pulled it into OpenRefine to do some preliminary data cleaning. So what this tool is great for is like removing blank spaces or non-Unicode compliant characters. And you can do that very, very easily rather than doing, so you don't have to do any coding or any Excel formulas to do that. Then I pulled a list of journal abbreviations and the full citation from Web of Science. This is available online. And I did this because I found that researchers were often in their citations using the abbreviation and not the full name of the journal. I wanted the full name of the journal, so I just used some Excel formulas to pull in the full journal name. And then I worked with Excel to extract DOIs from the data set. I just used a formula to do that. So having the DOIs would allow me to then understand which publishers we were citing. And then I pulled all of the holdings from our catalog, and that included things like ebooks, multimedia, articles, etc. So I had to pull this large file into Microsoft Access to filter out anything that wasn't a journal that we had in our holdings. And then I combined everything in Excel. So I pulled together in one big Excel file all of the citation data with all of our holdings data. And then I also pulled in the categories from Scopus so that I could look at which categories corresponded to which journals. And then once I had all of that data in one Excel file, I pulled it into Power BI to run analysis. And this is what it looked like on my dashboard. So now I'll just talk very briefly about some of the results that I found and what are some of the potential insights we could gain from doing this kind of exercise. So first, I looked at what publishers are we using, which is self-explanatory. We had about 2,000 different publishers that were cited. What journal packages are we using? This was extremely important, if we're looking at unbundling, goes without saying. What journals are we using? This could be used for things like reference and instruction, as well as understanding, the completeness of our collection. What year were most cited journal articles published? This was really important because we want to look at buying back files so we can understand, our former articles or journal articles useful to our researchers. And yes, yes, they were. And then we could break that down a little bit more. The next question was, which OA journals are we using most frequently? Again, for reference and instruction, this could be helpful. Which journals are being cited that we don't have in the collection? Again, this is really useful if we want to, buy one-off journals to add to our collection. And then what fields are we citing most frequently? And I would suggest that this is really important to look at because in collections analysis, we want, and as collections librarians, we also want to make sure that we're having, or that our collection is balanced in terms of who we're supporting. So this was really interesting to see. Now, what did I learn from doing this exercise? Some of the limitations I faced were that some older publications didn't have DOIs, which made it difficult to understand or to get some of the metadata associated with those journal citations. Another limitation was the source from when I initially, the source may have changed. So which publisher is publishing a journal might have changed over time. So we only have sort of a snapshot view. There were errors with how papers were cited because it was pulled directly from reference lists. I had some trouble with technology in terms of computing power with my laptop, which has since been figured out. And then I would also suggest that reproducibility in the arts and humanities might be a bit more of a challenge with using Scopus data that relies a bit more heavily on STEM fields. Some possible applications, I won't go through all of them, but some that I thought were really interesting were to fill gaps in collections or to fill out research guides if you want to partner with liaison librarians. We could also analyze citations in conjunction with counter reports to get a broader view of what's being used, and then maybe even understand some of our faculty's reading and publishing use cases. So from those results, we saw which journal packages were most cited, which can help us understand which journal packages are higher impact to our research community and which ones might be candidates for cancellation. I'm not sure why it says 111. Apologize. There are three questions there. I also envision citation analysis as being sort of a complement to using counter reports, not that it would replace it, but to use it in tandem with. To what extent does our research collection meet our authors' needs? Interestingly, our research showed that citations use library collections fell at about 60%. My data isn't fully clean. I expect that to be about 75 or 80%, which just goes to show that there is an appetite from our publishing faculty and students to use library collections. And then I'd suggest that further research is needed to look at OA and ILL usage rates to determine how our researchers might be obtaining access to information that isn't in our holdings, and how we can use this methodology to shrink the gap and improve the impact of our collections. And what's next? First, I'd like to compare, as I mentioned, findings to counter and ILL reports. We have access to a platform called Unsub, which helps us unbundle our big deals, which we haven't really leveraged, but I think we could use this information to build scenarios in Unsub and understand what our collection could look like a little bit better. I think it's really important, number 3, to interview faculty members and liaison librarians about journal usage and citation patterns to understand, just to understand what their needs might be, determine which journals are cited together in clusters, because if we are collecting, if we are acquiring one journal, we might want to collect journals that are cited sort of in clusters with that one, to make sure that our users are having access to everything that they need. And then finally, see if there's any opportunity to automate this process using things like Python scripts, which hasn't been greatly explored in this field, but I think that there's definitely an opportunity for it. And that wraps up my presentation. So I will turn it over to Eric. Thank you.
And I was muted. All right, so hi, everybody. So I'm going to start just talking about kind of the nuts and bolts of the tool that you saw highlighted kind of in both of these presentations, this data fetcher. And let me put this kind of in some context, because the tool's undergone some evolution over the last several years, and we're entering into kind of a new phase. So I'll kind of preface this whole section with this kind of discussion. It's in kind of an interesting run. So I started writing this tool about 5 or 6 years ago for my own purpose. I have a technical background, I was coding, and I just was responding to customer queries for data over and over, and finally decided to write something for myself that made that a little more automated. And then long story short, about 4 years ago, we started actually handing it out to specific clients here and there that had data uses for the kinds of use cases you saw today. And that's evolved through the years since. Through COVID and everything else. And so now what we're doing is actually we're entering into a kind of a new pilot phase of discovery, I guess, on how this tool and other kinds of solutions like it can actually help to support use cases like what we saw today. So the idea is that the data fetcher is one arrow in the quiver, one solution that is obviously useful in many ways. And what we'd like to start understanding is whether or not there are other solutions or other ways of addressing, especially common use cases that could evolve kind of next generation. So really, we're kind of trying to roadmap our own product development and using the data fetcher and the use cases thereof as an important way to inform that, to learn what are folks trying to accomplish, what are the kind of use cases that our existing products are sort of falling short. You can't just kind of click your way through Scopus.com and get it done. And so we're really interested in knowing that, so that we can start to think about what the next steps are, what the next phases of evolution are for this product. So what we're going to be doing, what you see here is the existing data fetcher webpage. So here's where you can go and you can download it. You can learn about it. You can download the manual, the user guide. We're going to be migrating to a mode where really we still will have the data fetcher supporting anyone that needs it. And we'd like to know what that need looks like. And so we're going to migrate to a more of a workflow where you basically express interest and say, hey, I'm trying to do this. And we say, okay, well, that actually is pretty interesting. And it seems like you can't get that done with our normal tools. Let's talk about it. And then work out the right solution, which could be data fetcher. Maybe there's other things that as we start working on new solutions and started developing next generation type answers, I'm really hoping that this whole space evolves into more even than just this tool. So we're kind of entering into kind of a larger picture, I guess, if you will. So with all that said, let's just kind of show what we have at the moment today. Oh, and there's also a new version, by the way. So if anyone today on this webinar is interested in the tool and would like to explore or has a use case that you feel it might support, please do get in touch. I'm going to have the email on our last slide of where you should go. Get in touch and let's talk, because what I'd like to do is work with you to figure out how best to support it. And in the case of the tool, I can actually get you the newer version of the tool, even than what's on the site here, which has some significant updates and stuff. So that's kind of the context of this. Now, the way it works, when you get it, the tool's right for you and it solves the problem is you get it, it gets downloaded into a zip file. So it's pretty easy. The thing on the left is just a Windows folder. So you basically just take what's in that zip file and stick it into a folder, say on your desktop or anywhere else. And that's the entire installation process. There's no setup.exe or anything else like that. You just copy and go. Once you have the file ready to go, you can launch it. And you can either put your credentials into the tool, or you'll notice here on the right, there's a little file that you'll notice in the folder where the tool lives. And you can put your key and your token in that little file. And the reason why some folks do that is because then you can copy that little file into, say, alternative directories if you create different projects. Because one of the things about the tool, since installing it is just a question of copying the files into a folder, you can replicate that folder. Say you have 3 different projects, you could just create 3 folders with the same files, and that way you can partition off the different queries and the different outputs that you're doing for each project. So it's that's kind of an easy way to do that. Now, one of the things that Lori had mentioned, which is important, is that the syntax, the language that the tool uses to perform a query in Scopus is the same language that is used in the advanced search of Scopus.com. And certainly what I advise strongly is that if you are using a query in the tool, to first vet it and explore it and test it in Scopus.com to make sure that the publications that are coming back are the right set. It's a lot easier and quicker to do it that way than to put it into the tool, download a bunch of stuff, realize you downloaded the wrong thing, and do it again. So that's slow. And so what you want to do is make sure you have it right in Scopus.com and then move it over. An alternative way to use the tool, and this was actually alluded to by Julie, is you can take a set of publication IDs, like Scopus IDs or DOIs. Let's say you have 1,000 DOIs that represent some piece of work or project or something from and you'd like to analyze those. You can tell the tool to simply use that list of DOIs. So we're not querying Scopus anymore. We're simply taking 1,000 DOIs and say, go get all these publications and the metrics thereof. So there's two modes of using the tool, really, querying and specifying a list. And then, as both noted, once you've done that, so step one is you tell the tool what it is you'd like to fetch, what publications you're interested in. And then part two is to tell it what do you want out of them? What would you like to know about those publications? And that's where that screen on the right shows an example. It's basically just a tree-like selection. So you just click your way through it and tell the tool, pick and choose which fields that you would like to export into your file or into the Excel. And that's kind of about it. You tell it what publications you want, you tell it what data you'd like about those publications, and you're off and running. Notice, by the way, it also has export options for a RIS file, RIS, for import into something like EndNote, and Scopus.com export format. So it will emulate what you get from the Scopus export, only with more data, if you need that. So an example export, I'm not going to spend too much time on this because you saw it in both presentations, but once you export the data, what it will do is it will stick the fields into an Excel file like this. If you choose, you can turn the Excel on or off. It will also do tab or comma delimited files for importing into things like R or Tableau and other sorts of visualizers. So we try to make the output flexible, even JSON format, if you have something that wants to read JSON or standardized JSON format. One of the use cases I'm working on right now, actually, is a client that was a little frustrated that the Scopus data you get from the different APIs can be structured differently depending on what you asked for and what the field you're getting, what the endpoint is. And what we can do here is I standardize the export format. So regardless of where the data comes from, it all lands on your hard drive in exactly the same JSON structure. So that makes it easier for downstream applications to use that data. And again, this is just another export that shows how for each author, you can get more information about authors than, so let's say, for instance, with a Scopus export, you also wanted to get things like publication range, like the year that they started writing, the year that they ended writing, or some other kinds of things that are harder to get from Scopus. So that would be a use case example where this tool might help. So we can get additional fields for each author and for each affiliation that's associated with the paper. This is an affiliation link. So we can, for each paper, you'll see the publication ID is listed several times. In fact, all of the publication. This is all one publication on the left. These are all the different authors, and these are the different institutions that each author listed for each publication. So we can get into some detailed analysis of what authors are associated with what affiliations on what papers for various use cases. The tool, it can also do network maps. So one of the common ways in which the tool has helped folks in the past are doing things like co-author network diagrams. So, so a common use as well, I just need to find out who all the different co-authors are in all the different papers that I'm downloading in the set of publications. And so what you're seeing here is an example of that. Here the tool is creating a special output file where it has on the left each author ID. So here you'll see this author 800 listed 4 times. And these are all of the co-author relationships of that particular author within this data set. So within the data set that we downloaded, this author has collaborated with this one 50 times, with this one twice, and with each of these people once. And finally, in the publication column are the actual publication IDs of every one of the publications that form that collaborative relationship. So here's 50 IDs would be in this column. So that's the sort of data that you could then import into like a Gephi or some kind of a visualization tool to create kind of a radial or other sort of co-author network diagram. This sort of export would be appropriate for. Another thing that the tool has done in the past, which is helpful, is normalize name forms. So what the tool can't do, it's actually on the call just this morning talking about this. Sometimes there's multiple records in Scopus for one author. Now we try to minimize that. We feel like we're the most accurate on earth with regard to this, but it's not perfect. And we still have examples of cases where, you know, one author might have a couple of records, and the tool doesn't do anything about that. But what it can do is it can standardize name forms for a given ID. So on the left, what you'll notice here is a network diagram. Now this is Voss Viewer. So Voss Viewer, we've downloaded a bunch of publications and we're saying produce a co-author network diagram from these publications. And one thing you'll notice is there's a KW Demis here on the left, but then over here on the right, you'll notice a K Demis without the W. This is something Voss Viewer does. It doesn't really normalize the names. This is the same individual, but some of the papers that were downloaded had a W and some of the papers didn't. And so it generated this dual locus diagram. One of the things that the tool can do is to normalize all of those name forms so that within a given data set, the name of any given author would remain constant for that one author. Now, if there's two Scopus records for Mr. Demis, then it wouldn't solve it. But if we have one record and the problem is that the name keeps changing throughout the publications, we can standardize that name form. So what you see on the right is the result of that. So here on the right is kind of the cleaned up version where there's just the KW form and you don't have the two nodes here with K and KW. So that's sort of one of the aspects of cleanup we can read. So some of the use cases in the past, and you know, if some of these apply or might apply to you, this is where we'd want to talk to you and understand what your needs are to see how best to work with you. Large exports is one. So some folks simply need to export more than what Scopus export can easily do. Especially what you can do in Scopus export, if you have a large export, is try to partition, say, by year. So if I have 10 years worth of data, I can download a year at a time. And if each one of those years has a number of rows less than what my limit is, I'm pretty good to go. I can just do the 10 downloads, stitch them together, and I'm fine. If that's not the case, and even within a given year, you have more than the limit, it can get much more awkward and difficult to try to partition the data in a way that you can get different data sets in all under the right amount and then stitch them together. The data fetcher will do the whole load at once, subject to your quota. Again, because the fetcher runs off API key quotas thereof, and so it still is within that boundary. But within the boundary of that, it will download everything kind of in one shot. So for large exports, it can be useful. Like Lori pointed out, things like social media policy citations and other kind of PlumX related data, it can stitch into the data set output fairly easily. If you're trying to do custom metrics, so standard H-index you can get fairly easily right from Scopus and export even from SciVal, et cetera. But if you're trying to do like a time limited, let me self-calculate an H-index within a certain period of time, or other kinds of custom metrics like that. Sometimes you just need the raw data. And sometimes the export capabilities of the tools might not get you exactly what you need. So those would be those kinds of use cases where it could be helpful. One of the use cases that we had was identifying institutions and countries citing the work of an institution. That's one we had. I had another use case where they said, well, I'd like to find all of our authors who anytime in the last 5 years have collaborated with anybody in India, because we have a delegation coming from India, and we'd like to put together a package that showcases some of the work that we've been doing with institutions in that country. So that was sort of an example of an interesting one. I won't go too much more. Yeah, that's sort of the bottom bullet is kind of that, things like that. So lots of different use cases there. And I guess that's it. So the way to do this now, moving forward, what I would recommend kind of is the best sort of the way to do this is you want to email that email address at the bottom here. So if you feel like the data fetcher, everything you've seen today or what I've discussed and you have a question, you're thinking to yourself, wow, I think this tool might help. What I would do is email that email address right there, datafetchersupport@elsevier.com. I get that. Some of our others on our team get that. And then what we'll do is we'd love to get back to you and discuss what that use case is, what you're trying to achieve. And certainly if the data fetcher is the answer for that, if that's the right tool, then then I can walk you through that, get you the latest version, walk you through how to use it and how to solve your challenge, your problem. Or if we have alternative and a growing list of alternative kinds of solutions, and we want to kind of plug you into that as well. So yeah, it's kind of our sort of our ecosystem of solutions, and this tool is one of them. I think that about finishes what I had to say. I think we have some Q&A perhaps.
Yeah,
Some questions.
thank you so much. Thanks to Lori and Julie and Eric for 3 really excellent presentations. That was great. I learned a lot about Scopus and about the data fetcher and some really interesting use cases. So yes, we have quite a few questions coming in, and some have already been answered. Thank you to Eric and Julie and Lori for answering on the fly there. I think I want to kick off with this question from David, which asks, I hope one of the speakers will compare Scopus ease of use and output with Google Scholar and Web of Science. So I don't know if any of you want to kind of tackle that comparison between the way you might use Scopus and the way you might use Google Scholar or Web of Science.
We actually don't have Web of Science, so unfortunately I don't have an answer to that question. In terms of Google Scholar, I haven't explored that too much. I find Google Scholar is a bit difficult to get data out of in sort of in a format that's easy to manipulate, and there's a lot more manual work to be done. This is with the data fetcher, you can just plug in your search fields and it'll export it right to a TSV file for you. So I unfortunately don't have much of an answer to that one.
I'll just chime in and say I agree with Julie. When I prepare these packets for faculty, I look at it as many different venues as I can to get the data. So I always include their Google Scholar information from their profile as well, but it's very difficult to get that data. It's a lot of manual work to manipulate it and even download it. We no longer have Web of Science. We've strictly now gone to Scopus. Web of Science data was fairly easy, and I would say comparable in terms of what you can export and use from Web of Science as well. Though I do find that Scopus, because it has a greater coverage of journals, that often, for example, their H-index will come out higher in Scopus, which we like, right? Again, we're trying to tell a great story for them as they approach their tenure promotion process.
Great, thank you. Thank you both. We've also had a few questions. Some have been answered already, but different questions around disambiguing journal titles, the bane of every bibliometrician's existence, right? Journal titles are very tricky. And Julie, I know you worked with the Web of Science title list to do this, and it looks like you responded to one question on this already. But I don't know if maybe anyone wants to chime in on kind of how we can make this easier. Lisa wrote here, I was thinking there might be an algorithm to run on the Scopus data so that, for example, 5 versions of the titles become 1. So how do we kind of work on this issue of journal titles having many different forms?
So I did answer that one, I think, in the chat. That was a really big problem for me. I found that, so the way that the data fetcher works is that it pulls the citations from from papers. So however a scholar has cited something is how you're going to get it in the citation list. I did a lot of manual cleanup. For the most part, it abbreviated the journal titles, in which case I was able to use the Web of Science abbreviation list to find the full journal title so that I could compare it to what was in our catalog, because we use the full title list or the full title name. But I did a lot of manual cleanup. Unfortunately, I don't have a good solution. I started with, doing VLOOKUPs between the two files. I was able to pull the Web of Science journalists into like a text file, and then get it into a format that I could do some just use some VLOOKUPs on it. And then anything that was left over, I actually had to like manually go through and clean it up and whatnot. So it's still ongoing. Like it's been a while since I started this, and it's not a quick process. And yeah, it's unfortunately like you get the data as the scholars have cited it. So yeah, it is a problem. It's a big challenge.
Yeah, definitely. And Manuel also in the chat here has mentioned PubMed has a journal list as well that could also presumably be parsed in a similar way for biomed journals if that's what your set is. So yeah, I think it's an ongoing issue, and you're right, because you're dealing with the way the author has actually cited it, right? It's hard to have kind of standardization and standard data that you're working with. And I don't know, Eric, if you want to talk a little bit. There were several questions about the when and how is this coming to Macs? So do you want to say anything about that?
I've been kind of typing answers into this Q&A thing. So it's kind of funny because I developed the app on a Mac. So originally it was a Mac app, and it still is. The problem is that Apple won't let you run a Mac app unless it's got the right sort of Apple certification. It has to be sort of anointed by Apple for it to be allowed to run a Mac. And so we don't have that yet. So we're kind of looking at that. And honestly, I've never done that before, and I don't have clue one about how to go about doing that. So we're looking into that. There are people helping me out to see what would be required to get that anointing to happen so that we could then allow the app to be run. And people have said, well, you can always just right click and say run anyway. Problem is that the application is built from hundreds of individual components that live in a little subdirectory. And what I found in personal experience is that you have to then right click on like every one of them as they pop up. So it becomes extraordinarily cumbersome. So really the solution is to get this thing properly packaged and done right as a Mac app. And so that's the good news and the bad news. The good news is it'll run on a Mac, an M1 Mac anyway. The bad news is we don't have it packaged up and distributable as a Mac app. And I don't know, I don't have a timeline on that. We're trying, I guess, but that's kind of where that is. I have another question that I could answer.
Sure, yeah.
I'm looking at a couple. One is, could the cleanup of alternate abbreviations be done for journal titles? So now we talked about journal titles. And the answer is kind of. And that feeds into the detail and disambiguation from Manuel asked, how can I go into details on how the disambiguated network graph, that boss viewer thing where it was cleaned up on the right and the left. The simple answer for that is, well, I just ran it twice. So what happens, here's the pragmatic thing. If you're downloading data from an API, let's say you download 10,000 publications, right? The first few hundred publications will come down, they have authors, and those authors have names. And so you're storing that stuff away as you build your data set of 10,000 publications. So I might be E. Livingston 5 years ago when I published my first paper. But then as I move down through the 10,000 papers, I get to that paper 6,057, and I show up again. And now I'm E.B. Livingston because I've added my middle initial to my name. Or some other name change has occurred, right? And so as I move through my process of downloading 10,000 publications, then my name will morph over time as I come down through, and all of that's getting stored away. Now, what happens on the left, that diagram you saw on the left, is that Boss Viewer will just take that whole thing, suck it all up, and say, well, there's an EB Livingston, there's an E Livingston, those are two people, we'll put them like that. What I do, what the tool does, is it builds a running record, like an authoritative combined record for each author. So when I get downloaded on paper number 3, there's a certain amount of information about me. It sticks that away on the side and says, all right, here's what I know about Eric. But then a few more papers down the line, it has another affiliation, it's got another name format. It says, oh, but I know more about Eric. I want to stick that in there too. So by the time it's done, it's built up a conglomerate, an aggregation of information from all 10,000 papers, and any of them that include anything about me, it's stuck into this one record, which is kind of the golden Eric record for this data set. Then all I have to do is click, well, do it again. And what happens is every time this tool does a server query, a pull, a job, it saves what it did on the hard drive, so that if you ask it to do it again, it's not going to be so silly as to go back and re-request all that information from the server twice. It saves it. It knows it just asked for it. It's not going to ask for it again. So instead, it reads all that information back off your hard drive instead of the server, which, first of all, it makes it run 10 times faster because it's just reading right off your drive and just going along. But the second important thing is now it's pulling all the information about me from that golden record that it built over the last pull. So when it gets to that paper number 5 again, and it says E. Livingston, it says, no, I know a lot more about this guy now. This is actually E.B. Livingston, because that's the last name he used on paper number 6057. That's the name I'm going to use. So it standardizes the information that it outputs because it's drawing all that information from that record that it built in the process of pulling it the first time. So that's kind of the way it works. So it basically saves it all up, remembers it, and then when I tell it to do the output, it's doing a known standard format to produce all that output. Now, unfortunately, it doesn't at the moment. It's an interesting idea. That's why I'm kind of cogitating a little. It does not at the moment do that for sources like journals. So each journal is still tied to each paper. So paper number 5 lists journal X, and if paper number 6057 also lists journal X, but with a different name, it will still list the different names. It'll say, well, paper 5 had this source and paper 2000 had that source. But to your point, it's interesting because journals have source IDs. So it would be possible to build one of those little golden records and store everything I know about journals and then standardize the journal output format across the data set if you were to ask it to do it again. So interesting. Yeah, so it could, it just doesn't right now, but maybe in version 8.
There you go.
Maybe it'll do that.
Right. Great suggestion. I think we have time for one more question. Well, maybe not. We're about 2 minutes. But I do have an interesting question here from Michael. Maybe we could get a really quick comment or response. Has anyone tried to map a topic area in general? For instance, I'd like to show my poli-sci department how research on elections has been going in recent years and perhaps compare it with their own profile. So not just citation mapping, but just publications by subtopic. And the first thing I think of is SciVal, which is a tool that does exactly that really, really well. But any way to do that in Scopus?
I mean, I can just offer up real quick. I mean, obviously we have the ASJC, the All Science Journal categories, but it's a very general level, very high level. There's only about 320 of those categories. For topic areas, we typically do sub-analysis. So like one of the things that the data fetcher does is does a topic modeling process where it can actually use word, noun, phrase, co-occurrence frequencies to try to batch papers into sort of organically grown categories, if you will. I'm not sure if that's exactly what we're talking about here, because they're not predefined topic areas. So to do that, you really want to do SciVal. That really is a core competency of that tool.
Perfect for SciVal.
It is, and actually note that the tool, by the way, can download those things. So when you download information from, if I were to do a search in Scopus for 1,000 papers, among the things I can download for those papers are their SciVal topics. So you
perfect. Oh, that's an interesting connection. Yeah.
And SDGs too. So you can
download and sustainable development goals.
Exactly. All that can come down with the data.
Perfect. All right. Well, with that, thank you so much, everybody. I'm going to pass back to Sabrina, who's going to close us out.
Great. Thanks, Emily. Yeah, I'll just say thanks so much to Lori, Julie, and Eric for taking the time to speak with us today. Thank you to Emily for moderating the Q&A, and thank you to our attendees for your engagement with your questions and comments. I'd like to remind our viewers that we did record today's program, so be on the lookout for a follow-up email from Choice and ACRL with a link to the archive version. Also, if you have a few minutes after the presentation to fill out a brief survey, we would really appreciate it. So thanks again to all of you out there for joining us. We hope you learned something new from the session, and we hope to see you again in the near future on another webinar.
Great. Thanks so much,
Thank
everybody.
you. Thank you.
Bye.
Thank you.